All right, guys. Let's talk business. Don't worry. It's not going to last too long. Notice it's just a one pager today. All right. So check it out. There's only two ways that they can present this type of information. Well, there's many ways, but the two main ways. They either ask you bluntly, directly, they just say, hey, look, find the area of this region right here. Just find it. Or they put it in context, like the question you have in the back. This is a contextual question. They're not telling you to find the area of the curve, but you're going to have to eventually because it means something. So let's just do the context. Let's just do the blunt questions first. The ones that they just say, just find me the area. Does everyone have a calculator? Okay, make sure you grab a calculator, guys. Prefer these right here because these are faster than those big chunky ones. So this, or faster than the colored chunky ones, but not faster than the non-colored chunky ones. Okay, I'm going to take out my calculator. Here's my calculator. And this one's coming from the 2003 exam. Yeah, maybe your parents took this one here. All right, so check it out. It just says, this is, I don't know what question number it is, but I'll look at the rubric in a little bit. It says, let R be the shaded region bounded by the graphs y equals square root of x and y equals e to the negative 3x. And the vertical line x equals 1, as shown in the figure to the left. Find the area of R. Guys, for all of you guys, it's going to look the same because there's only like one major way to do this. All right, focus, guys, focus. So hopefully we know, but if you don't, it's okay. You have a calculator. But hopefully you know that this equation there, that one is the square root of x1. It's one that's going through the origin, right? Or that's the end point. And on this one right here, the one that's decreasing, that one is y equals e to the negative 3x. And then this vertical line, that's the x equals 1. Do not use calculator syntax. Type this one into y1. This is just for notes. Type this into y2. Do not type calculator syntax in your work. So I'm going to take my calculator. And I'm going to go on y1, and everyone do this with me. I'm going to type in square root of x, so square root of x. And then y2, I'm going to type e to the negative 3x. E, so the e is where the log button is, or 7, or the 4, sorry, the 4 button is, or ln, but push the second button to the negative 3x, like so. And then before you push graph, if you just have it under normal, it's not going to graph. See, well, I mean, it is, but it's a little very small section. Click on window and make the window like this one. So I'm going to say, let's see, I'm going to say negative 0.25 to 1.25. So negative 0.25. You can make it negative 0.5 if you want. To 1.25. And then y minimum negative 0.25 to 1.25. So let's see how it looks. Graph. Yeah, that looks pretty good. I mean, you know, I think we could have made it look better, but it looks pretty good. What do we want? I know we can't see it here, but we want the shaded region from where it intersects all the way to here. So I need to find this x value right. I need to find this x value. Can you guys see the cursor? I need to find this x value right there. So how do I do that? Second, calculate what number? 5. And I'm gonna. If you only have two curves, you can just push enter, 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 and it only intersects one time. So you don't even have to move the cursor. If it intersected more than once, then you'd have to move it closer to the one that you want. Push enter, and there it is, 0.2387341. So what I would have done here, I would have probably, remember, you're just going to get a book. You can maybe do a quick sketch where that doesn't take you more than 25 seconds or 20 seconds. It doesn't have to be perfect. And then I would say that value where it intersects is 0.2387341. Let me see if I can remember all that. My memory is pretty bad right now, but I'll try. Why can't I? There it is. So I can't see my little mouse. Okay. What was it again? 0.2387. 0.238741. 341. And then what would I do, guys? I would not hold it like that. I would do a little arrow, and I would go down the alphabet. A. Now, I am warmed up, guys, because I did this morning. They did not go down the alphabet when I looked at the rubric. It's okay. You don't have to be like it doesn't have to look like exactly like the rubric. All right, here we go. I'm going to go integral. Because what do I want? I want this area right here, that shaded region. See? I'm going to start at A. You're not starting at 0. You start at A. And I'm going to end at 1. Upper minus lower. They didn't give the names of these graphs. They didn't call it F or G. They just said Y equals square root of X, Y equals E. So if they don't give the names, do not give it a name. Just go ahead and just say square root of X. That's the one on top. Minus, what's the one on the bottom? There it is. And then put the dx. It's up to you if you want to put parentheses like that to indicate height versus the delta x. But it's okay if you don't. The dx means that it's the end of that integral. So either like that or with parentheses. Man, I'm really bad today. I'm going to get some sleep or try at least. All right, so there it is. That's probably most of the points right there. So now you're going to go to your calculator. You know what? I haven't even saved this to A yet. So let's second quit. I'm going to push X, store A, make sure that it's that same value. Let me see. Yep, it is. And then I'm going to go math, number 9, from A, alpha A, all the way to 1. And you already have it stored, guys. So I'm going to go alpha trace Y1 minus alpha trace Y2. Make sure you know which ones you're putting in there. And I'll put an X, and I'll slow down right now. 0.4426, that's the answer. Let's say you would have gotten a negative. Guys, this will never be negative because you're just finding areas. So like unsigned areas or unsigned areas, they're always going to be positive, upper minus lower. So if you would have gotten a negative, you know something's wrong, that you just reversed your things. 0.4426299. This equals 0.4426299. How many digits after the decimal? At least 3. I recommend you put 4, 5, 6, at least 3. So this could have been 0.442 or it could have been 0.443. Let's look at the rubric. Yeah, I know there's more questions than this, but we don't know volume yet. What's 2003? Okay, let me take out 2003. It's already here, guys, because I took it out this morning. At least I thought I did, yeah. Okay, look at the rubric for 2003. Let me maximize it. All right, here it is. Yeah, look. Okay, so first it was worth 2 points. Third with the correct limits, but it also counted for B and C. Oh, let me erase that. All right, they use the letter T and S. Why did they choose T and the letter S to use? I don't know. Maybe the alphabet RST or something. They call 0.238734 the letter T, and they use the lower limit as a T. Do you guys see that? Guys, I would just go down the alphabet, A, B, C, D, F, G, and so that's what I would do. So we still got the whole point. Look, they gave 1 point for the integrand, that is this expression up here, and 1 point for the answer. Notice the answer could have been 0.442 or 0.443. Could we have done that? Yeah, and then don't worry about letter B or C. We haven't done volume yet. Letter B is volume. They're rotating this about a horizontal line. And the region, yeah. So we're not ready there. We're not there yet. That's the unit 8. We'll talk about it when we get there. All right. So there it is, guys. What you guys think? All right. So let's see. This is from 2004. Do you guys want to take a 30-second head start? See if we can do this. It's the same type of thing. You get to use the calculator on this. So take a 30-second head start. See if we can figure it out, guys. This was the first day in a long time that Usually I just wake up, but I didn't wake up this time. So that's my body telling me that either I'm getting old or I need more sleep. All right. I'm going to go ahead and get started, guys. If you're so close to getting it, keep going. Let f and g be the functions given by, and they give us names this time. They call this one f of x. They call this one g of x. I'm going to type f of x into y1. Do not use calculator notation. I'm just doing this for good notes, right? And I'm going to put that in y2. The graphs of f and g are shown in the figure to the right. Find the area of the shaded region enclosed by the graphs f and g. So I'm going to go to my calculator, and I'm going to type y equals, and I'm going to type, can you hook me up with the f, Konduro? I already forgot it. 2x, open, 1 minus x, close. That's it. Okay, what was g of x? 3. X minus 1, close, square root of x. Okay, there it is. There's y1 and y2. Sorry, I'm going to close the door, guys, because I keep hearing random noises. Here we go. I'm gonna go to my home screen, and I already know. So let's look at this first. My lower limit is 0, so let me go ahead and write it. Integral. Okay, look, Chav, I don't know what's on top. Draw a vertical line. Integral. What's my lower limit? 0. What's my upper limit? 1. It's a perfect 0. It's a perfect 1. And then what curve is on top? So use the name f of x, and what curve's on bottom? G of x. I would not bother typing in the expression. Correct math is correct math. From here, I would just write out the answer. You have a calculator, so I'm going to go, there's my f of x, there's my g of x, so I'm just going to go math, 9, 0 to 1. I don't see any issue. And I'm going to go y1 minus alpha trace y2. I'm going to push x on this guy, and I'll push enter, and there it is, 1.1333333. 1.133333. As many threes as you want. It actually goes on forever. All right, here we go. Context. So we're going to do this together. I need you guys to ask me questions because I need you guys to be on your A game. Ready, Salali? So I need you guys, so everyone, let's be on our A games for this. Let's see what we have here. There are 700 people in line for a popular amusement park when the ride begins operation in the morning. Okay, so there's 700 people in line. Once it begins operation, the ride accepts passengers until the park closes 8 hours later. Okay, that makes sense. So they start operating, they start letting people in, and then 8 hours later. While there is a line, people move onto the ride at a rate of 800 people per hour. Okay, let me see if I read that. While there is a line, people move onto the ride at a rate. Okay, so this is how many people get in the ride in, right? I'm going to put right in and right out. The graph above shows the rate R of t at which people arrive at the ride throughout the day. Okay, so you know what? Let's just change the vocabulary. The graph above, I'm going to put right, but don't worry. We're going to pick right now, right in and right out. The graph above shows rate R of t at which people arrive at the ride throughout the day. The time t measured in hours from the time ride begins in operation. Okay. Sorry, guys. Let's get our thoughts together in order. They gave us, look what it says. While there is a line, people move onto the ride at a rate of 800 people per hour. So that's how fast people are getting into the ride. So maybe I shouldn't say right in, because then they immediately after that they tell us this. The graph above, well, it's not above, but I stole the words above, but the graph to the right. The graph to the right shows the rate R of t at which people arrive at the ride. So this is the amount of people that are arriving at the ride. And this is the amount of people that are getting on the ride. Does that make sense? So let me go ahead and so let's go ahead and use our vocabulary. This is ride out, and this is ride in that are getting into this is the amount of people getting there. There's the amount of people leaving the line. They're leaving at a rate of 800 people per hour. That's how fast the ride is taking people. People go, the roller coaster or whatever it is taking 800 people per hour. And let me go ahead and change the vocabulary here. The graph above, the graph to the right. To the right. Sorry, I didn't get a chance to modify it the right way, but that's fine. Before I continue, is everyone okay? Okay, just in case you don't want to say, 800 people per hour are getting on the right. Right? So every hour there's 800 people that are getting it. And this graph on the right is how many people are getting on the right on the line. Like there's a line and they're getting to the line. Cool. Okay. This is the ride in and this is the ride out. Like how many people ride the roller coaster per hour, and how many people are riding to the roller coaster. But if there's more than 800 people per hour, then the line's getting longer and longer, right? And if there's less than 800 people, then the line's getting shorter. Yeah, hopefully that makes sense. All right, here we go. How many people arrive at the ride between t equals 0 and t equals 3? They're not counting the 700 people that are already there. They're just already there, right? So I guess the park opened and they're not in operation yet, so the line was already there. But the t equals 0 is exactly when it starts in operation. So how many people arrive at the ride between t equals 0 and t equals 3? Well, think about it, guys. I'm going to find the integral between 0 and 3 of r of t. And this is r of t. Chav, I don't understand what you're doing at all, not even a little bit. This is how many people arrive, right? Look at the units. People per hour times hours is going to give you people. So between t equals 0 and t equals 3, whatever the area under this graph is, that is how many people arrived. I'll get something to eat. That is how many people arrived during that 3 hour time set. Does that make sense? Or does it not make sense? Okay, so we're going to use geometry. And by the way, I am warmed up because I did it this morning. But this morning I cut this up into 3 pieces, and then I saw when I saw the rubric, I'm like, oh, they broke it up into 2 trapezoids. So I'm being full disclosure. I already saw the rubric. They broke it up into 2 trapezoids. Do you guys see that trapezoid like that, and this trapezoid right here? So they did that. So here we go. So this first trapezoid, base 1 is going to be 1,000. Plus base 2 is going to be 1,200. Times my height is going to be 2 divided by 2 plus, and then I'm going to write 1,200 plus 800 times 1 divided by 2. All right. I'll stop here real quick because I know some of you just care about points, but I don't want you to be like that. But if you're one of those that like, I want to maximize my points, you can leave your answer like that, and that would be your answer point as well. You can leave your answer like this, and that would be your answer point. But I don't want you to, though. I don't want you to, though. Do you have a calculator? And on this one, you can use your calculator. So just use your calculator. I guess these twos right here will cancel out. Let's see. 2,200 plus 12 and 8 is 2,000 divided by 2, 1,000. Oh, that one's easy. You don't even need a calculator. 3,200 people arrive from t equals 0 to t equals 3. You probably don't have to say all that details. You could just probably just say 3,200 people. You can just answer the question. But I like that. I feel like the way the exam is going is it's better to answer the question with sentences. So try to have a good habit, but not a big deal. Are we okay so far, guys? Okay, let's see. If you really understand the question, I think you'll get letter B correct. Is the number of people waiting in line to get on the ride increasing or decreasing between t equals 2 and 3? Okay, so between t equals 2 and 3, well, I think we're going all the way to 4. Between 2 and 3, this little part, is the number of people in line increasing or decreasing? All right, Chop, I don't know. I see a graph going downhill. Relax, hold on, relax. How many people are getting on the roller coaster per hour? 800 people per hour. Is the rate that our people are coming into the line larger than 800? So that means the line, there's more people coming in than going out. So if there's more people coming in than going out, then the line is getting what? Longer. Do you guys see what we just did? But Chav, the graph is decreasing. Guys, relax. If you were to take the derivative of this, it's decreasing, but That just tells you the rate at which people are entering is decreasing. That's all that means, right? But they're not asking for that. Maybe I said too much. Maybe I'm confusing you guys. There's more people coming in than out. So I'm going to write since, what am I going to write? Let me see. Since R of t is greater than 800, and I'm going to put in parentheses 800 people per hour are leaving, quote unquote, the line, comma, the line is increasing between t equals 2 and t equals 3. Let me see if all that made sense in English. Since R of t is greater than 800, and then in parentheses, I told them what it is. 800 people per hour are leaving the line because they're entering the roller coaster or the ride, whatever it is. The line is increasing between t equals 2 and t equals 3. Does that make sense, guys? Does that make sense? Does it make sense? If it doesn't make sense, let me know because I can't read mine. Since the rate is bigger than 800, Chav, why is 800 such a big deal to you? Because there's 800 people per hour that are leaving the line because they're getting in the roller coaster. The line is increasing between t equals 2 and t equals 3. Done. I think that's full credit right there, guys. What do you guys think? Yeah, they should have just called this problem the line problem. There's a line, and people are either entering a roller coaster or getting on a line. Or they're getting on a... Yeah, I bet you a lot of English learners probably had a hard time with that. I know, because, well, okay. What do you think? Well, what? No, ask. Oh. All right, letter C. At what time t is the line for the ride the longest? Oh, that's kind of like what we were just talking about right now. How many people are in line at that time? Justify your answer. Okay. When is the line the longest? No, not at 2. Not at 8. No, at 0, there's 700 people in line. When is a line the longest?
Okay, there's 700 people, and there's 1,700 people, and then 800 of them go on the ride. Then there's 1,100 people. And then
No, not 4. No, you do. At 3. Why at 3?
Why at 3? I don't know. Because it's 800.
Yeah, it's okay, guys. Let's go back to that 800.
So what does that mean?
Yeah, let's talk. Maybe we should have done a water problem instead of a people problem. Okay. Yeah, look, guys. Okay, everyone. Again, 800 people per hour get on that ride. This is constant. It's always going to be 800 people per hour. After 1 hour, 800 people. After 2 hours, 1,600 people have gone on the ride. After 3 hours, 2,400 people. It's always going to be 800 people per hour. Always. This is how many people are arriving to that particular ride. As long as I'm above the 800, that line is getting longer because look, there's more in that are going out. There's more people coming in than people are coming out. See, 1,000 people per hour are coming in. Well, I can only take out 800 people per hour. So within the first hour, that's a net gain. If it were to be 1,000, that's a net gain of 200 people. See? So of course it's increasing right here. As long as I'm above the 800 mark, the line is getting longer. The line's getting longer, the line's getting longer, the line's getting longer, the line's getting longer, the line's getting longer. Boom. Right at t equals 3 hours, the same amount of people coming out is the same amount of people coming in. So right at the 3 hour mark, the line is like not, it's zero. The rate of change is 0. Yeah. Right at the 3 hour mark. As soon as this passes below 800 or goes down below 800, now the line is getting smaller because there's more people going out than in.
Wait, but what if there does not be a line at all?
No, the line keeps getting longer and longer and longer and longer. The rate of change got to 0. Not the line is at 0. The line, there's more people on the line, more people on the line, more people on the line. At 800, it's a max. There's a lot of people on the line. The rate of change is 0, so the line's not increasing or decreasing. Now the line is decreasing until there's no more people on the line. Maybe by this time there's no more people. We haven't figured out when there's no more people. But does that make sense? Does that make sense? So Lolly, does that make sense? Okay. So here we go. I'm gonna say, let's see, how do we write it? Since, no, let's see. So 800 is the biggest one. So I'm gonna say since R of t is greater than or equal to 800 from t equals 0 to t equals 3. And then R of t is less than 800 after t equals 3, comma, absolute max must occur at t equals 3. Let me see if that makes sense. Since R of t is greater than 800 between t equals 0 and t equals 3, and then R of t is less than 800 after t equals 3, absolute max must occur at t equals 3. Absolute max of people of the okay, absolute max. Let me put it in parentheses. So I like the way everything sounds. Absolute max, and then I'll put it here. Right as longest line. Longest line at t equals 3. Absolute max, longest line at t equals 3. Yeah, you have the longest line at t equals 3, period. That's when it happens for sure. Does that make sense to you guys? As we get more experience, we will write it differently. Guys, I put a lot of thought on how I'm saying this. When we look at the rubric, once we get more experience, we'll start saying it the way the rubric does. You'll see it right now. But for now, I think this is simple. This is written simply, and it's correct. If we were to take the AP exam and I were to be reading this, I'd be like, yeah, that's she said. You guys, because together she, you guys, yeah, you said that correct. That's perfectly right. You didn't say anything wrong. It is going to be the longest line at t equals 3. All right, good job. You got the point. You would talk specifically about
setting like 800 to like where like the x-axis would be, like, you know how like if it's above the x-axis.
yeah. Sometimes they write an equation and you create a new one, like you give it a name. They didn't tell us that to do that. And 800 is the big mark. That's like, you know what I mean?
So because it's above the x-axis.
Yeah, above the 800 number. But we're not there yet, so don't worry. Just focus on saying correct things. You know what I mean? So, and this is correct, right? With what we know. All right, now they want to know how many people are in the line. Oh, how are we going to figure that out? The amount of people that were waiting in the line, add them all up, and subtract how many people have gone. Okay, so let's add up all the people that have come to the line. So how many people were in line in the very beginning? 700. And I'm going to add all the people that came in the line. So that means the integral from 0 to 3 of r of t dt. We already did that, didn't we? Okay. And then I'm going to subtract all the people that have left. What's the rate of change for people leaving? 800 people per hour. So it's going to be 800 times what? 3. So let me go ahead and put this for good notes. This is in. And this is out. Do you guys see that? All right, so here's the answer. So let's see. 700 plus 3,200. So 789. So that's 3,900. So 3,900 minus 8 times 3, 8, 16, 24. Minus 2,400. So that is, what is it? That is how many people are waiting in line. 1,500 people in line at t equals 3 hours. Well, hopefully, this is realistic. Like, hopefully it's a ride. 800 people per hour. You'll take care of this. Okay. Yeah. Oh, yeah. You work in Texas. Look, this is like you. So you should show your boss this question. And all right. Look at this. Look what this is. Look what this says. I'm surprised that they put do not solve, given that you have a calculator that you probably could have solved it. All right, guys. Think algebra. Write, but do not solve an equation involving an integral. So they want to see an integral of r whose solution gives the earliest time t. So they want to see the word t and r. at which there is no longer a line for the right. Okay, so let's read it again. Write but do not solve an equation involving an integral expression of r whose solution gives the earliest time t at which there is no longer a line for the right. They're asking your question, Kunduru, when they want to know when there's no more line. All right, well, check it out. Let the previous answer help you out. Check it out, child. Let the previous answer help you out. I'm not picking on this. I just wanted to. Ooh. Oh, can someone open the door? Okay. Yeah, all right, look, guys, let this question help you out. Didn't this tell us how many people were in line at t equals 3? Yeah. So it's probably this equation without that number 3, because that number 3 was the time value, right? There it is. We got it. So look, so what is it? All right, so think about it. All right, check it out. Ready, guys? Yeah, you're just going to set it equal to 0. So look, 700 plus integral 0, but you're not going to put the number 3. What letter am I going to put? Did they say A? No, they said T. Because we want to sell. Yeah, we could put A if you want, and then say A equals T. But just write into T. Is everyone okay with the T there? And then I'm going to put R. You can put R of. I'm going to put R of X. It's okay if you put R of T dt, but usually you want to have, physics does it all the time, but usually you want to have a different letter. It doesn't matter once you do the antiderivative. And then I'm going to put minus what? 800t. And then I put what? Equals 0. And there it is. That's an equation. You want to put a different letter besides t, but you can if you wanted to put R of T dt, that's fine. You'll be fine, but there it is, like that. What do you guys think? Let's look at the rubric. Let's see how they wrote it. 2010. All right, here it is, guys. 2010. Nope, that's not it. All right, here it is. Look, by the way, every free response question is worth how many points? 9. Put in there, this is our first one that we've done fully. Look at letter A. How many points did they give us for this one? 1 for the integral and 1 for the answer. So these are usually about 2 points. So now you know that area under curves are usually about 2 points. They'll give you a point for the integral and a point for the answer. Look at letter B. Look how they wrote it. Let's see if I like my answer better or their answer. The number of people waiting in line is increasing because people move into the right at a rate of 800 people per hour, and between 2 and 3, R of T is greater than 800. Oh, okay, I like that. I still like mine better. They're both equal. Do you like theirs better? Okay, I like mine better. Yeah, it means the same thing. Letter C, how many points? 3. Look at this. Identifies T equals 3, number of people in line, and justification. Let's see. R of T equals 800 only at T equals 3. Between 0 and 3, R of T is greater than 800. Between 3 and 8, R of T is less than 800. Therefore, the line is longest at time T equals 3. Okay. There are 700 plus 32, 1,500 people waiting in line. We got the full credit. We said what they said. Cool or not cool? All right, let's see letter D. Yeah, everyone's is going to look like that. They chose the letter S. It doesn't matter what you put on the inside. Guys, everyone's answer is going to have to look like that. Unless I guess you could put R of S minus 800 on the inside. That's the only way. The only way that it could be different is if you do this. This is the only other answer that I can think of that would be the same. 700 plus integral 0 to T R of X minus 800 dt. And if you think about it, if you put some thought into it, it's the same. Because this is like your net gain, right? Look, antiderivative of E. Oh, I would have gotten it wrong. Oh, no. I'm so stupid. I would have gotten it right. I was looking at this one thinking that I put a dt there. It's right here. Notice that there's no t on it. What's the antiderivative of 800? With respect to t? 800t. Oh, look. It's right there. 800t. So this is the only other answer. I have a big butt. Okay. This is the only other answer that would have been taken. Yeah, today is just one of those days. Okay. Is all this making sense, guys? Are we cool? All right, congratulations. You guys are all passing your AP exam. No, did we understand this? All right, guys, we have 45 minutes. I'm going to leave you guys your time for your time. Take care of business.